Salar de Uyuni is the world's largest salt flat at 10,582 square kilometers. It is located in the Daniel Campos Province in Potosí in southwest Bolivia, near the crest of the Andes, and is at an elevation of 3,656 meters above mean sea level. The salar was formed as a result of transformations between several prehistoric lakes. It is covered by a few meters of salt crust, which has an extraordinary flatness, with the average altitude variations within 1 meter over the entire area of the salar. The crust serves as a source of salt and covers a pool of brine, which is exceptionally rich in lithium. It contains 50 to 70% of the world's lithium reserves, which is in the process of being extracted. The large area, clear skies, and the exceptional flatness of the surface make the salar an ideal object for calibrating the altimeters of Earth observation satellites. The salar serves as the major transport route across the Bolivian altiplano and is a major breeding ground for several species of pink flamingos. Salar de Uyuni is also a climatological transitional zone, since the towering tropical cumulus congestus and cumulonimbus incus clouds that form in the eastern part of the salt flat during the summer cannot permeate beyond its drier western edges, near the Chilean border and the Atacama Desert. Formation, geology and climate. Salar de Uyuni is part of the Altiplano of Bolivia in South America. The Altiplano is a high plateau, which was formed during uplift of the Andes Mountains. The plateau includes fresh and saltwater lakes as well as salt flats and is surrounded by mountains with no drainage outlets. The geological history of the salar is associated with a sequential transformation between several vast lakes. Some 30,000 to 42,000 years ago, the area was a part of a giant prehistoric lake, Lake Mincian. Its age was estimated from radiocarbon dating of shells from outcropping sediments and carbonate reefs and varies between reported studies. Lake Mincian later transformed into Paleolake Taucar, having a maximal depth of 140 meters. And an estimated age of 13,000 to 18,000 or 14,900 to 26,100 years, depending on the source. The youngest prehistoric lake was Coipasa, which was radiocarbon dated to 11,500 to 13,400 years ago. When it dried, it left behind two modern lakes, Pupo Lake and Ururu Lake, and two major salt deserts, Salar de Coipasa and the larger Salar de Uyuni. Salar de Uyuni spreads over 10,582 square kilometers, which is roughly 100 times the size of the Bonneville Salt Flats in the United States. Lake Pupo is a neighbor of the much larger Lake Titicaca. During the wet season, Titicaca overflows and discharges into Pupo, which, in turn, floods Salar de Coipasa and Salar de Uyuni. Lacustrine mud that is interbedded with salt and saturated with brine underlies the surface of Salar de Uyuni. The brine is a saturated solution of sodium chloride, lithium chloride and magnesium chloride in water. It is covered with a solid salt crust varying in thickness between tens of centimeters and a few meters. The center of the salar contains a few islands, the remains of the tops of ancient volcanoes submerged during the era of Lake Mincian. They include unusual and fragile coral-like structures and deposits that often consist of fossils and algae. The area has a relatively stable average temperature, with a peak at 21 degrees Celsius in November to January and a low of 13 degrees Celsius in June. The nights are cold all through the year, with temperatures between -9 and 5 degrees Celsius. The relative humidity is rather low and constant throughout the year at 30 to 45%. The rainfall is also low at 1 to 3 millimeters per month between April and November, but it may increase up to 70 millimeters in January. However, except for January, even in the rainy season the number of rainy days is fewer than 5 per month. Economic influence. The salar contains large amounts of sodium, potassium, lithium and magnesium, as well as borax. Of those, lithium is arguably most important as it is a vital component of many electric batteries. With estimated 9 million tons, Bolivia holds about 43% of the world's lithium reserves. Most of those are located in the Salar de Uyuni. Lithium is concentrated in the brine under the salt crust at a relatively high concentration of about 0.3%. It is also present in the top layers of the porous halite body lying under the brine. However, the liquid brine is easier to extract by boring into the crust and pumping out the brine. The brine distribution has been monitored by the Landsat satellite and confirmed in ground drilling tests. Following those findings, an American-based international corporation has invested $137 million to develop lithium extraction. However, lithium extraction in the 1980s and 1990s by foreign companies met strong opposition of the local community. Locals believed that the money infused by mining would not reach them. There is currently no mining plant at the site, and the Bolivian government does not want to allow exploitation by foreign corporations. Instead, it intends to build its own pilot plant with a modest annual production of 1,200 tons of lithium and to increase it to 30,000 tons by 2012. Salar de Uyuni is estimated to contain 10 billion tons of salt, of which less than 25,000 tons is extracted annually. All miners working in the salar belong to Colchanes Cooperative. Because of its location, large area and flatness, the salar is a major car transport route across the Bolivian Altiplano, except when seasonally covered with water. Name: Salar is salt flat in Spanish. Uyuni originates from the Aymara language and means her pen. Uyuni is also the name of a town that serves as a gateway for tourists visiting the salar. Thus, Salar de Uyuni can be loosely translated as a salt flat with enclosures, the latter possibly referring to the islands of the salar, or as salt flat at Uyuni. Aymara legend tells that the mountains Tunupa, Cusco and Cusina, which surround the salar, were giant people. Tunupa married Cusco, but Cusco ran away from her with Cusina. Grieving Tunupa started to cry while breastfeeding her son. Her tears mixed with milk and formed the salar. Many locals consider the Tunupa an important deity and say that the place should be called Salar de Tunupa rather than Salar de Uyuni. Flora and fauna. A part of the Incahuasia Island inside the salar featuring giant cacti, James flamingo, culpi, Bolivian vizcacha, Andean goose, Andean hill star, Andean flamingos in the Laguna Colorada, south of the salar. The salar is virtually devoid of any wildlife or vegetation. The latter is dominated by giant cacti. They grow at a rate of about 1 centimeter per year to a height of about 12 meters. Other shrubs include pilaya, which is used by locals to cure catarrh, and thola, which is burned as a fuel. Also present are quinoa plants and quinua bushes. Every November, Salar de Uyuni is the breeding ground for 3 species of pink South American flamingo, the Chilean, Andean and rare James's flamingos, the color presumably originating from feeding on pink algae. There are about 80 other bird species present, including the horned coot, Andean goose and Andean hill star. Andean fox is a representative animal, and the islands of Salar host colonies of rabbit-like vizcachas. Tourism. Hotels. Salar de Uyuni attracts tourists from around the world. As it is located far from the cities, a number of hotels have been built in the area. Due to lack of conventional construction materials, many of them are almost entirely built with salt blocks cut from the salar. The first such hotel was erected in 1993 to 1995 in the middle of the salt flat, and soon became a popular tourist destination. However, its location in the center of a desert caused sanitation problems, as most waste had to be collected manually. Mismanagement caused serious environmental pollution and the hotel had to be dismantled in 2002. New salt hotels were built near the periphery of the salar, closer to roads, in full compliance with environmental rules. Train cemetery. One major tourist attraction is an antique train cemetery. It is 3 kilometers outside Uyuni and is connected to it by the old train tracks. The town served in the past as a distribution hub for the trains carrying minerals en route to Pacific Ocean ports. The rail lines were built by British engineers arriving near the end of the 19th century and formed a sizable community in Uyuni. The engineers were invited by the British-sponsored Antofagasta and Bolivia railway companies, now Ferrocarril de Antofagasta of Bolivia. The rail construction started in 1888 and ended in 1892. It was encouraged by Bolivian President Anacito Arce, who believed Bolivia would flourish with a good transport system. But it was also constantly sabotaged by the local Aymara indigenous Indians who saw it as an intrusion into their lives. The trains were mostly used by the mining companies. In the 1940s, the mining industry collapsed, partly because of mineral depletion. Many trains were abandoned, producing the train cemetery. There are proposals to build a museum from the cemetery. Satellite calibration. Salt flats are ideal for calibrating the distance measurement equipment of satellites because they are large, stable surfaces with strong reflection, similar to that of ice sheets. As the largest salt flat on Earth, Salar de Uyuni is especially suitable for this purpose. In the low rain period from April to November, due to the absence of industry and its high elevation, the skies above Salar de Uyuni are very clear, and the air is dry. It has a stable surface which is smoothed by seasonal flooding. As a result, the variation in the surface elevation over the 10,582 square kilometer area of Salar de Uyuni is less than 1 meter, and there are few square kilometers on Earth that are as flat. The surface reflectivity for ultraviolet light is relatively high at 0.69 and shows variations of only a few % during the daytime. The combination of all these features makes Salar de Uyuni about 5 times better for satellite calibration than the surface of an ocean. Using Salar de Uyuni as the target, ICESat has already achieved the short-term elevation measurement accuracy of below 2 centimeters. With the use of modern GPS technology, it can now be proved that the Salar de Uyuni is not perfectly flat. New measurements revealed previously missed features resembling ridges, hills, and valleys only millimeters in height. They originate from the variation in material density, and thus the gravitational force beneath the salar's sediments. Just as the ocean surface rises over denser seamounts, the salt flat surface also rises and falls to reflect the subsurface density variations. Gallery. Salar de Uyuni 2013. Sunset at the Salar de Uyuni. Piles of salt at the Salar. Llamas in the Salar. The Salar covered with water. Small patch covered with water during winter. A Taiwanese monk at the Salar during winter.